Hello guys. As far as the NCERT exercises of 1.3 and 1.4 are concerned, we are going to discuss in this session only. So let's begin with the first exercise that we have considered, that is 1.3. In the first question, we have to prove that square root of 5 is irrational number. So do check my video in which I have proved square root of 11. Alright, so the same steps are going to be there. Just like square root of 11, we will be able to prove square root of 5 too. We have to take the this number square root of 5 to be a rational number, and we are going to prove this irrational by the method of contradiction only, in which the assumption part is to take the opposite that we need to be proved. Alright, so everything has been explained as far as square root of 11 is concerned in the video that I have made earlier. So in the same manner you can prove square root of 5. So let's see what question number 2 has to say. Alright, so here comes question number 2. In this question, we have to prove that 3 plus 2 square root of 5 is an irrational number. In fact, this particular question also we have discussed in the irrationality proof of the numbers in the video itself, the previous video itself. So you can see the previous video and you can prove 3 plus 2 square root of 5, because I have taken this question only as an example to prove the irrationality of the numbers. So you can check it out in the video, and this can also be proved by the method of contradiction, in which obviously we have to assume something that are needed to be proved as the opposite of it. Okay, so here we need to prove irrational number. Then we will be assuming that 3 plus 2 square root of 5 is actually a rational number. Alright, so we have done this also, and you can see in the video, you can watch in the video too. So let's see now what we have to do in question number 3 of your NCERT 1.3. So in this question, we again have to prove the irrational number. So to prove that, the following numbers are irrational numbers. Alright, so let's see what are the following numbers. So to begin with, the first part that we need to prove is that 1 divided by square root of 2. Alright, so as far as this part is also concerned, we have discussed the same part in the previous video also. So you can check the previous video and you can get the complete solution how to do this type of question. However, this is also going to be proved by method of contradiction itself, and if you want to get the proper description and proper explanation of method of contradiction, you can check the video itself. The method of contradiction is well explained in that too. As far as the second part is concerned, okay, let me tell you something more about the first part, that is 1 divided by square root of 2. In this question, we need to rationalize this particular part too before we apply method of contradiction, or you can call it before we can solve this, we have to rationalize it. And why we need to rationalize, everything has been explained in the previous video. You can check it out from there itself. As far as the second part is concerned, let's see what we have to do in the second part. So we have to prove, okay, so we have to prove in the second part also that 7 square root of 5 is an irrational number. So it is also very much simple. So what we can do is we can simply take this number to be a rational number. Again we have to apply the method of contradiction itself, and we will be able to prove. However, just for a glimpse, I can tell you that after taking this 7 square root of 5 to be as a rational number in the form of p by q itself, we will shift over there and we will find that rational divided by rational will end up with rational, and ultimately we will meet with the contradiction that how come a rational number will be equivalent to the irrational number, which is square root of 5. So by this method of contradiction itself, you will be able to solve this part also very easily. Alright, so let's see what part number 3 has to say. So as far as the part number 3 is concerned, we have 6 plus square root of 2. However, we have discussed the previous one. It is just like the same one. As far as this 7 is concerned, when it moves on the other hand, it will be going to division part. In the same manner, this 6 will move over there in the negative part because it has been associated with the positive sign over there. So again, rational minus rational will end up with rational, and ultimately we will meet with the contradiction that square root of, say, rational minus rational will end up with rational, and here we have irrational. Then how come this whole rational part will be equivalent to the irrational part? It won't be possible. It can't be possible. Hence, we will meet with a contradiction, and ultimately we will say that our assumption will be incorrect. And ultimately this number 6 plus square root of 2 will be proved as an irrational number. So this is how we can complete our exercise 1.3. It is a very simple one, but guys, let me tell you one thing very much clearly, that you have to watch my previous video in which the irrationality part and the method of contradiction part. These two conceptual things you must be aware of in order to understand and in order to excel in exercise 1.3 very easily and smoothly, so that you will be able to score good marks in your examination. Okay, so let's see exercise 1.4 and what are the major things which are associated with exercise 1.4 of your NCERT book. All right. So, you know what? Before we will take the questions of 1.4, we have to know few of the prerequisites that are needed to be there before we start with the exercises question. All right. And the first thing that come up with this regard will be the rational number. So, I'm just revising what exactly we have studied in rational number. Alright, so as far as the rational number is concerned, we have already discussed and we have seen in the video also that these numbers can be represented in the form of p by q, and these p by q form, alright, these p by q form have some of the attribute associated with them. That the first one is that P and Q must have to be coprime. We have discussed that also. That means other than 1, it should not have any other common factor between them. And as far as the Q is concerned, the second attribute will be, as far as the Q is concerned, Q cannot be equals to 0. If Q is going to be 0, then the whole number, which is P by Q, will become not defined. These things we have already discussed as far as the rational number is concerned. So this P by Q form is the first representation that we can represent rational numbers. As far as the decimal numbers are concerned, okay, the second representation is in the form of decimal numbers. So how we can represent decimal numbers as far as rational numbers are concerned? So decimal numbers can majorly be categorized as in two categories. The first category is terminating decimal kind. Alright, so terminate, as the name itself suggests, terminating. Terminating means that the decimal number is going to terminate. Say for example, 3.57. So that's it. The number has ended here. 3.57. After 7, there is no other number. As far as the second example is concerned, it's 0.765. 0.765. The second example we can consider. Similarly, we can consider negative 3.87675. So this is the terminating examples. So as you can see, the number has already terminated over here. However, there can be one thing in your mind too, that after decimal, after this 7, after decimal this 7, we can write zeros over here too. Yes, we can write zeros over here, but that zero has no significance. Hence, we don't write usually. All right. So another category or another classification of decimal number is concerned. The first one we have seen the terminating kind, and the second one, as far as the rational number are concerned, they are known as non-terminating. That means the numbers are not going to be, terminate. They are not going to end. But there is another thing associated with the non-terminating part, is that the numbers are going to repeat. Now, let's see this attribute with the help of an example. As you can see, I'm writing over here the example 6, the first example, 6.373737 and so on. These points represent that the number is not going to terminate, they are not going to end. It will lie till infinity, You can keep writing it. So the repetition of the number is here. Hence, non-terminating as well as repeating. And another way of writing this number, instead of writing 4 times, 3 times or 10 times, we can simply write 1 times like this, 6.37 over bar. So the numbers which are repeating, we put simply on that numbers means the digits, on that digit a single line over it. So this line represents that these 2 digits are going to repeat. Okay, so let's see another example, like negative 3.7777 and so on. All right, so again, it is a kind of a rational number itself of decimal kind of non-terminating and repeating one. So here you can see we can write like this only, negative 3 decimal, that means the point 7 over bar. This bar represents that this 7 is going to not end. This is not going to end. It will keep on repeating. So what we have seen that the rational numbers usually can be represented in 3 major categories. The first one is by P and Q form, and the second one is terminating as far as the decimal numbers are concerned, terminating, and the third one is non-terminating but repeating. So why I am recapitulating these all things? Because you need to have these basic knowledge before we jump into exercise 1.4. All right. So let's see some of awesome features associated with these 3 stuffs, these 3 things that I have highlighted, and which these 2 parts are the sub part of the decimals one. Okay. So let's see. So as far as all of the 3 parts are of the parts of rational number itself. Okay. So let's see another property of these terminating one. So as far as the terminating numbers are concerned, so if we need to convert these terminating numbers, these terminating decimal numbers in the form of P by Q, okay, in the form of P by Q, so they are going to have a very important factor associated with them. These are that if we are going to convert these all 3 numbers, for instance, for example, we are taking, if we are going to convert these all 3 numbers, that means the terminating number, in the P by Q form, then we will come to know an amazing property about Q as far as the terminating decimals are concerned, and that Q will have only in the form of 2 and 5 factors. That means if you are going to convert this number, say for instance 3.57, you are going to convert it into P by Q form that I'm going to show, then the Q will have only as a factor of 2 and 5. Maybe 2 can be any numbers, any number times. Say 2 times, 3 times, 4 times, depending on what type of number we are taking. As far as, and same thing goes with the 5 too. That 5 will have, the factors of many repetitions. It can possibly have. So let's see this example. It will make the things more clear. So we can write 3.57 just like this. 357 over 100. As far as this Q is concerned, now this 357 is P part and 100 is Q part. So as far as, according to this property, this Q, that means 100, will have the factors of 2 and 5 only. Okay, 2 and 5 only. Let's see this by simply doing the prime factorization of this 100. After doing it, say we are performing over here, 100, 50, 25, 5, and then we are done. So as you can see, there are these 2 and 5 only. So as far as the hundreds factor are concerned, we have only 2 and 5. Here, 2 is coming up 2 times and 5 is also coming up 2 times. So the thing is, here 2 and 2 will become M and N simultaneously, and the whole agenda and the whole focus is that whenever the terminating decimals are there, then the Q part, after converting into P by Q form, the Q part will have the factor of 2 and 5 only. There will be no other factor than that. Okay, as far as the terminating is concerned. So this one of the most important and attractive property of terminating decimal kind we have seen. Okay, you can perform by your own the other also. Let me solve this too and try to explain it more clearly one more time. So as far as the number is concerned, we have 0.765. If we remove the decimal, we have to put 1000 on the denominator part. So now after again performing, this was the original number. It is of terminating kind. After converting into P by Q form, we got Q to be 1000, and after performing the the prime factorization on 1000 part, we can get 2 power 3 and 5 power 3. The main thing that we have to understand is that the factors of 1000 or the Q part will be 2 and 5 only. However, this n represent how many times of 2 are there, and this m represent how many times of 5 are there. So in this scenario, we got n to be 3 and 5, 5m to be 3, 2. So these are, these are the factorization. And one thing also must be kept in mind is that n and m are non-negative integers. They are always going to be non-negative integers. All right. So this was one of the most fascinating part or feature that you people might have come to know about. So you can perform the third part also by your own, just like the first and the second part I have performed. So let me tell you, like 1, 2, 3, 4, 5. So it is going to be 387 or negative 387,675 over 10,000. All right. 1 second. Not 10,000. It is going to be lakh. 1 stands 100,000, 10,000 lakh. It is going to be lakh. So the Q part is going to be lakh. And after prime factorization, you will come to know that the prime factors will be 2 and 5 only. Hence, this property can be understood very easily. All right. So that is one of the most fascinating stuff. So let's see. We have seen the terminating part, one of the most important feature of the terminating part. Now let's see what we have with non-terminating and repeating kind. All right. So before moving on, let's see the terminating only, or what are the things that are associated with the terminating. Then we are going to move on to the non-terminating part. So another thing that we can see is that, okay, I think we have seen this. What I'm showing over here is, okay, let's see the terminating part itself and see what other features and other things that can be seen out of it. So what we have seen that after converting terminating decimal into p by q form, the q will have a factor, the q will have the factors of in the form of 2 and 5 only, where n and m can be non-negative integers only. All right. So non-negative, or you can call it the positive only. So one thing is also must be kept in mind that the converse, okay, the converse part of this property is also true. We are going to look into that too. So we have seen these all things we have already seen. So let's let me tell you about the converse part of this property. That means whenever the terminating numbers can be converted into p by q form, the q is going to be in the form of 2 and 5 only. The factors are going to be 2 and 5 only. It can be any numbers, any times. Its converse is also true. That means if the say if we have a rational number in the form of p by q form only, and if the q part is going to have the prime factorization of 2 and 5 only, then we can directly write that p by q number is actually, the rational number is actually a terminating kind number. So its converse part is also true. I hope you have understood what I meant by that. So like I have written over here, if q has a factor of 2 and 5 only, can be of any numbers, any times, where n and m are obviously represents the times, 2 say 5 times, 3 times, 4 times, doesn't matter, whereas 5 similarly. So n and m must be non-negative positive integers. Then if this thing comes, that means q has the factor of only 2 and 5, then p by q form of the number of rational kind will become terminating decimals. If you are going to apply that in the calculator, you will get that the numbers that we are getting will be of terminating decimal kind. Alright, so the converse is also true. So we can simply take an example just like that. Just let's see an example. Say we have 2 by, say this will end up with 1,000 only. Okay, so this number basically represents 2 by 1,000. Alright, so as we can see that if any number has a factor of 2 and 5 only, it will end up with terminating decimal kind. So this example very much can explain that the whole the converse part, the whole converse part of the property is also true. Okay, so that is it. Like another, if we are going to take the example, say 2 over 2 to the power of 3 and 5 to the power of 10, that means this number, which will ultimately will end up with 2 let me write it, 2 divided by how many, there are 3 2's and 10 5's. Okay, so it will it will be end up like 2 over 7 8 1 2 5 000. And if we are going to hit it into the calculator, we are going to get, so this is the number, this will be more visible over here. So this is the number. So we will get, what we will get? We will get 0.0000000256. Okay, so this has already been verified in the calculator itself. So we can see that any number p by q form has a factor of only 2 and 5. It will end up, as far as the decimal numbers are concerned, it will end up of terminating and terminating kind of the decimal numbers. So we have seen that. So terminating kind of the decimal number. All right. So we have discussed these things now. So moving on, we are going to discuss, okay, its converse is also true. So I'm writing over here, its converse is also true. So we have seen this part also, the first part and the second part. All right, so let's, okay, so that is it. Good. So let's see now non-terminating but repeating kind of numbers. So what are the things that are associated with non-terminating and repeating but repeating kind? So this is one of the most important thing that we should know and we should always care about, because this topic we have already done in class 9th. However, my 9th class kids can also take benefit out of it. So let's take an example. Okay, so this is I have written an example 6.37373737 and so on. It will end till infinity. Okay, so basically this is what? This is of non-terminating. That means the number is not ending, not terminating, and the numbers are repeating. Now what we are going to do is let's apply the same thing that we have done in the terminating part. Let's see what will have the factors of q. If we are going to convert this number into p by q form, then what kind of factors does q have? So it is very much clear that it will not have only 2 and 5. It will have other than 2 and 5 also. So it can have 2 and 5, but the other numbers will also be there. It can have also 3, it can have also 7 or any other number, 11, 17, whatever the numbers. It can be any other numbers apart from 2 and 5. Or maybe there will be no 2 or no 5 will be there. So the whole, what I'm trying to say is that if it is of non-terminating kind, then other than 2 and 5, the factors are going to appear. Okay, so this means that I'm just explaining over here that only with other numbers, and the same thing I am just giving example and making the things more understandable over here. Say okay, say this is the number and this was the, so apart from this, so there will be another number, say only 2, another number, or 5 with another number, or it can be with 2 and 5 with another number. So we can see, so it can have any of the 3 of the scenarios. It can have only 2 with other numbers. This number we are talking, p by q form. When we are going to convert this whole number into p by q form, then the q will have the factor of 2 along with other numbers, or 5 along with other numbers, or 2 and 5 with another numbers. So in short, it will have other numbers than 2 and 5. That's what this whole descriptive explanation meant over here. Okay, so this is something that is very much required before we move on further. So let's perform. So let's as far as the p by q form is concerned, we are going to convert this number into p by q form, which we have already done in class 9th also. So let's take the same example. So the number was 6.37373737 and so on. We can write it as many as time we can. So this number can be represented like this also, with a bar over the repeating digits. And the objective now here is to convert this number into P by Q form. After converting this P by Q form, we are also going to see that what kind of factors does Q have. That was the prediction, that it will have out of 3 categories, it can have any one, or it can have another category also. That means neither 2 or nor 5 is coming up. Maybe the whole number, the factors of Q will be totally different. We'll see later on after solving this number in P by Q form. Let's see. Okay, so we have done this in 9th also. So what we are going to do, we are going to consider this whole number, this number to be in. We are going to consider this whole number, and we are going to just let it, that this whole number, we are letting it to be X. Okay, so now what we have to do, we have to count how many digits are there which are actually repeating. So fortunately here are only 2 digits. So what we are going to do is, we are going to multiply by 100 on both the side of the equation. Excuse me, 100 by LHS, also 100 by RHS. What will happen if there were 3 digits? We are simply going to multiply it by 1000. What will happen if there will be 4 digits? We are going to multiply it by 10,000. So what will happen? Just for example, only one digit is repeating. Then we will multiply it by 10 only on both the sides, on LHS and the RHS. However, here there are 2 digits, so we are multiplying it by 100 on LHS and RHS sides. So what we'll get? So this point will be shifted over here, okay, and it will become like this: 6.37.373737 till infinity it will go, and here we will get 100x after the multiplication. So we are going to name this as equation 2, and the previous one as to be equation 1. So in the next step now, we are going to subtract equation 1 from equation 2. So let's perform this subtraction, but before that we need to show this, that what actually we are subtracting. So we are subtracting equation 1, here is the equation 1, from equation 2. After subtracting, we can write the whole the statement like this, and we are actually going to perform the subtraction. So these will kill off, this will cancel out, and ultimately we will get 0 on the decimal part, and this will end up with 1, 3 and 6. Okay, so this whole LHS part we can write it like, okay, so 100 minus x will end up 1x. It actually means 1x, x means 1x. So this will become 99x. So we can write the whole LHS part as 631 and the whole RHS part to be 99. So here 99 times x, so we will shift 99 over there, and we will get this number. Now this number has this number can be written as 6. The original number was 6.3737. so this is the P by Q representation of this number. So if you are going to check it in the calculator, you will get the same thing. Okay, so let's see the previous talk that we have been talking, that what this Q will have as a prime factor. So it will have 11 and 3 and 3, 11 times 9. So after factorization, it will be like 11 times 3 and 3. So the fourth category that I guess I have told you that either the prime factorization of the denominator will have 2 along with the other numbers, or 5 along with the other numbers, or 2 and 5 along with the other numbers, and there is another one that there will be no 2 and 5 and other numbers will be there. So the fourth category they are falling. In short, there will be other numbers than 2 and 5 as the factor. So there are no 2 and 5. Alright, so this is quite a fascinating attribute or the feature that we have discussed over here. Okay, so here we have seen the first category. No, it hasn't fallen in the first one, neither in the second one nor in the third one. So the fourth we can call it not even with 2 and 5. That means the whole the factors of q can be of other than 2 and 5 also. So that was it. So we have seen how the numbers behave as far as the decimal numbers are concerned when we convert it into p by q form or vice versa. Okay, so this can be checked from the calculator itself. So this number is actually this 6 by divided. So we have seen this also. So it looks like the calculator is showing the number is ending, but actually no, it is not. It is due to the restriction of the the screen is concerned. If the screen will be more and the programming of the calculator will be more, then the digits will be non-ending. That means non-terminating. So that was it. So that was the whole description. So we can see one more time over here, divided by 99. So we are going to get the numbers till infinity. Okay. All right. So moving on. So now we are going to see exercise. So now we are going to see exercise 1.4 and the first question. So what the first question is stating? It states that without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or a non-terminating decimal expansion. So the first there are 1 to 10 parts. So we are going to see only one part in order to understand, and I hope that you guys have understood it. So we are going to understand that how this whole thing works. So the second part we have considered. The number is 17 over 8. So what we are going to do? We are going to perform the prime factorization of 8. Okay, and we are going to see that what the prime factors of 8 will be. It will be 3 times 2. Okay, so as we are looking, it has only if the q are going to be only 2 and 5. Okay, then the number is going to be terminating. Here the factors are of q will be 2 times 2 times 2. That means it has a factor of only 2. That means it is going to be of terminating. Okay, so it is going to be of terminating kind. Here 3 is a positive integer. It is not coming up any negative because the numbers are simple, pretty much the same one. So n is a positive one. Okay, so it is going to be terminating number. So what we can take out the meaning of the whole concept. We can take that after analyzing the factors of q. If the factors of q if the number is in the form of p by q, then if the factors of q are going to be falling in either of the categories, that means q have only the factor of 2 and 5 or only 2 or only 5, then this whole p by q number is going to be of terminating decimal kind number. So this is something that we can infer and that we can get out of this whole explanation of these examples and questions that we are considering. Okay, so we can, all right, so these are the things that we can take out. So similarly we can we can do rest of the see the second part we have done. So there are 10 parts total, so rest of the 9 part can be understood and can be done easily. Okay, so there is no need to solve from my point of view, there is no need to solve each and every part. The major part was to make you understand. So I guess you guys have understood it now. So let's move on to question number 2. Write down the decimal expansion of those rational numbers in question 1 above which have terminating decimal expansion. So after doing question first part, in which we have mentioned which of them are going to be the terminating one. So I have took only the second part to explain, and in the previous question we have took only second part, and after performing it we have decided and we have wrote it that 17 over 8, see here, 17 over 8 was terminating number. So it was the terminating number. Okay, so so it was just the terminating number, and after getting that this is a terminating number, we are going to convert it into P by Q form, because that's what the question is asking. So what we have to do is, as we can see, the denominator have only 3 times 2. I mean 3 the factors of 2 are 3 times. So the objective here is to make these individual 2, and we are trying to make it or trying to convert it into tens. Okay, so in order to do that, after converting into 10, we will get 1000, and we will simply convert this into decimal one. Let's see how we are going to do. So we are going, in order to make these 2 into 10, we are going to multiply the numerator and the denominator part by 3 5s. Okay, so here we have done, in order to convert it into 10 10 10. So here we will get, after performing, because this have no significance, hence we can write like this. So after converting into 10, we are going to get like this, and 5 5 5 will get 125, and after multiplying 17 times 125, first of all we are going to consider the denominator 1. So this thing becomes 1000. As you can see, 10 times 10 times 10 is 1000, and after multiplying 17 times 125 in the numerator part, we will get 2125, and after counting 3 digits we can put the decimal over here. So ultimately this number can be converted into 2.125. So this is how we can perform the conversion of those numbers which are actually of terminating kind by simply converting, and by observing and by performing the prime factorization of the denominator part. So let's check it out, what we have done is actually true or not. So 17 divided by 8, it comes 2.125. So as you can see how beautifully we can convert the terminating numbers which are in the form of P by Q directly into decimal, and decimal into P by Q form. Simultaneously we have seen in question 1 and 2. The things has been explained in 1 and 2 very effectively. Okay, so that was the whole explanation of question number 2. Okay, so we have seen this terminating. I'm just putting the question reference, that terminating one. Only we have to perform the these things on the terminating one. So let's see question number 3. What question number 3 has to say. So so let's see what question number 3 has to say. The question states that the following real numbers have decimal expansion as given below. In each cases, decide whether they are rational number or not. If they are rational number, then convert it into P by Q form. And what can you say about the factors of Q? So let's see in question. So question number 3. So this particular question has basically three major parts. Okay, in the first part we have to check whether the numbers are rational or irrational. If they are rational, then we have to provide or convert the rational number into P by Q form. And also we are going to tell, or we are going to mention the factors of P and Q too, without actually performing the factorization. So it has this question number 3 has majorly 3 subparts. So we are going to perform and we are going to solve this question. However, let me tell you one thing, my friends. Question number 3 is one of the most important question because this covers many things in it. And as far as examination is concerned, this is also very important. So do pay your utmost attention. Let's see the first part. Here in question number 3, there are 3 parts, and I am going to solve all the 3 parts over here. So let's see the first part. The number is like this: 43.123456789. So the number here terminates. So this number is of terminating kind number. Okay. So as it is of terminating kind, so we can convert it into P by Q form. It is very simple. We have done since, I don't know, maybe since 5th or 6th class how to convert terminating numbers into P by Q form. So we are going to simply count the digits. How many digits are over here? Here 1, 2, 3, 4, 5, 6, 8, 9. So there are 9 digits over here. So we are going to remove this point and we are going to put 1 9 times 0, and the whole number will be converted into P by Q form. The first part we have done. What was the first part? That we have to classify whether this number is a rational number or not. So indeed it's a rational number, and that to be of terminating kind. So after that we have to convert this number into rational part. That means P by Q form we need to convert. Rational means P by Q form we are talking right now. So here I am going to convert. So there are 9 digits. So you can see here how many zeros are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 digits of zeros over there. So the second part has been accomplished very effectively. Now the third part. What will be the factors of Q? So the factors of Q are going to be only in the form of 2 and 5 only. There will be no other factors than this. However, if you are going to perform the actual factorization, you will come to know that that 2 will have 9 repetitions, so 9, and also 5 will have 9 repetitions. After, if you are going to perform the prime factorization of this number. So obviously there is no need to do that. You can simply write directly. However, there is one more thing you can keep in mind, that the zeros, the total numbers of 0 can be written over here. So if there are 9 zeros, you can write 2 to the power of 9, and similarly 5 to the power of 9 you can write it. So the first part has been explained well enough. So let's see the second part, guys. So what the second part is here, what we have here. So the number is like this: 0.120, 1200, 12000, 124 times 0, and the number will go on in this manner only. So what we are come to know about this, that the number is non-terminating, and also the number is non-repeating also. So as we are pretty much aware that the numbers which are non-terminating and non-repeating are actually the irrational numbers. So this number is actually an irrational number. Hence, it cannot be converted into P by Q form. So we can't perform any other thing on it. We can simply write it that the number is irrational number. And hence we will be done with question number 3's second part. Okay, hence it cannot be converted into P by Q form. Okay, So let's see what part 3 has to say. So part 3 is like this: 43.123456789, and we have a bar over there. That means, excuse me, that means the numbers are going to be non-terminating. The numbers are, this number is non-terminating kind. It is not going to be terminating. Hence, yes, indeed, this number is a rational number, and we are going to convert this number of a rational number in P by Q form also. So we have seen the conversion of non-repeating decimal numbers into P by Q form in the video itself. So you can apply the same methods. You can apply the same method and same steps in order to convert it into P by Q form. This I am talking about. So we have taken taken the example of this number, and you can compare it with this, and you can follow the same procedures that we have followed in order to convert this number into P by Q form. Okay, so we will ultimately end up with P by Q form conversion. Alright, so after performing this, you can also write in the last third part also, you can write as far as the Q factors are concerned, it will fall in either of the 4 parts that we have discussed, and that means that either it will have only 2 and other numbers to be the factor of Q, or it will have 5 with other numbers to be the factor of Q, or it can have the factors, other numbers will be there, or simply it will have other numbers instead of 2 and 5. So you can write the the feature of Q also, the factor feature of Q also. So this was it. So we have discussed each and every part of exercise 1.4, and we have understood the questions over here. So hope it was helpful for you people. Okay.